Hello. Now I'm here for a very important topic, Harber's method to factorize some polynomial. So we are given a polynomial, this one, g of x, and it is needed to factorize this polynomial. Since this polynomial is of degree 4 and it is a complex one, so Harber's method is the best method to factorize this completely. So if you see the Harber's method in the previous video, we needed a number like that. This is -2. So this -2 was available with us in this example because we were dividing this polynomial by x plus 2 and we set x plus 2 is equal to 0 and found x is equal to -2. So we can initiate this Haber's method in this example. But now in our today's case, this number is not available with us with which we can initiate the Harber's method. So how can we do this? We have to look for a number uh, which can make this g of x equal to 0. So this is a hit and trial method to search for a number which can make this g of x is equal to 0. So I have to check one by one for the few numbers which can make this g of x is equal to 0. I am initiating with x is equal to -1. So this g of 1 is g of -1. We have to set -1 on both sides, -1 power 4 plus -1 power 3 minus 5 square of -1, then -1 and -6. So what is this? 1 minus 1 minus 5 minus 1 -6. So this is not equal to 0. So it means that this x is equal to -1 is not our required number. So I can check for x is equal to 1 also. So what is at x is equal to 1? So g of 1 raised to power 4 plus 1 raised to power 3 minus 5, 1 raised to power 2 plus 1 -6. So this is equal to 1 plus 1 minus 5 plus 1 -6. So this is also not equal to 0. So it means that this x is equal to 1 is not our required number. So now I have to check for x is equal to 2. So g of 2 is equal to 2 raised to power 4 plus 2 raised to power 3 and minus 5, 2 raised to power 2, then plus 2, -6. So what is this now? This is 16 plus 8 minus 20 plus 2 minus 6. So this is equal 24 and 26. So now this is equal to 0. So it means that this is our required number with which we can initiate the Haber's process. So now look how we carry out this one. Coefficient of x raised to power 4 is 1. Coefficient of x raised to power 3 is 1. Coefficient of x square is -5. Coefficient of x is 1. Here x is alone, so its coefficient is 1. And next is -6. So we have to write here this 2. We will write here this 2. And like I explained in the previous examples, we will write here 1 and then we will multiply this 2 by 1 and then we will put the answer here under this 1. So this is 2, 1 plus 2 is 3 and now we will multiply this 2 with this 3. So answer is 6. We will write answer here. So negative 5 plus 6 is 1. Next, we will multiply this 2 with 1. So this is 2, 1 times 2. And 1 plus 2 is 3. So now we will multiply this 2 with this 3. 2 times 3 is 6. Negative 6 plus 6 is equal to 0. So this is our first result about this. So now we can write this one 1 as coefficient of x cube, because uh, if you see at the start here at g of x, this is x raised to power 4. Now after one step of synthetic division, its degree is reduced to 3. Now this 3 is the coefficient of x square, 1 is the coefficient of x, and then this is plus 3. So now we have to look for another number who with which we can uh, do synthetic division once more. So now we have to look for this one. If I choose x is equal to 2, no, negative 3, let me use this one. Negative 3 cube plus 3 times negative 3, this is cube. Negative 3 square plus 1 times negative 3, and this is plus 3. So this is equal to negative 27, and this is plus 27, negative 3 plus 3. So this is actually equal to 0. So now we can carry out the synthetic division with the help of this number x is equal to negative 3. So we can write this thing here as it is this. Okay, this is 1, this is 3, 1, and again 3. This is combined Harber's method or combined synthetic division. If we do it more than once, nothing new, same thing. Now I'm writing here this number x is equal to negative 3, at which this polynomial gave me 0. So negative 3, we will write this one as it is, and now we will multiply negative 3 with 1, which is equal to negative 3, which I will write here 3 uh, minus 3 is again 0. So now I will multiply this negative 3 with this 0. This is equal to 0. I will write here this 0. And then 1 plus 0 is equal to 1. And now I will multiply this negative 3 with this 1. Negative 3 times 1. This is equal to negative 3. So 3 minus 3 is again 0. So this is the way to factorize this one, do the synthetic division. So at the end is again 0. So we can proceed to factorize this polynomial now. So our one root was this one, x is equal to 2 on the left of the screen, and this x is equal to negative 3 in red. So, okay, what will be the remaining thing from here, from here? This is the coefficient of now x square. This is the coefficient of x, which is 0. And now this is a constant, which is 1. So how can we factorize this? 1 is x is equal to this 2. So I'm writing everything here again. X is equal to 2, x is equal to negative 3, and next this is the factor x square plus 1. So if you take this 2 on the left side, this will become x minus 2. Now we will write this in brackets. And if you take this negative 3 on this side, this will become plus 3x plus 3. And this is x plus 3. Now I will write this one here within brackets. This is x squared plus 1. So this is actually the factorization of the given polynomial, which is x raised to power 4 plus x cubed minus 5x squared, and next term is plus x minus 6. So plus x and minus 6. This is equal to, if you multiply these factors with each other, you will get this polynomial. Okay, so it means that this is the factorization of this polynomial. So a question may arise in your mind that why we have not factored this one, x squared plus 1. This has no real factors. So we cannot factorize this furthermore because we cannot find any real number which can make this 0. We don't have any real number that we set in place of x and we get answer 0. So we cannot proceed further with this one because we don't have any number which can make this polynomial equal to 0. So this is our required factorization. Hopefully you have understand this topic. This is basically the application of the Harber's method. Which application is this? In this example, we learned that Harber's method can be used to factorize the polynomial completely. Thank you.